Welcome to my final exam video presentation for discrete math. The agenda for my presentation: I will discuss conditional statements, their negation, inverse, converse, and contrapositive. I'll then talk about logical equivalent propositions, specifically tautology. I'll discuss logical inference and use the examples of resolution and disjunctive syllogism. And lastly, I'll talk about quantifiers and their negation. What are conditional statements? A conditional statement is a if P then Q statement. The example and symbol for that is P arrow Q. If Peter gets a 90% on the final, then he will receive an A, is an example of a conditional statement. The negation of a conditional statement is P and not Q. An example of this is Peter gets a 90% on the final and he does not receive an A. The inverse of a conditional statement is putting a negation sign in front of P and Q. The example for this is if Peter does not get a 90% on the final, then he will not receive an A. The converse is swapping the propositions Q and P. And an example of this is if Peter receives an A, then he will get a 90% on the final. The contrapositive is not Q. If not Q, then not P. The example for this is if Peter does not receive an A, then he will not get a 90% on the final. What is a logically equivalent proposition? A logically equivalent proposition means that when the P and Q values match for each side, they will either both be true or both be false. The symbol for logical equivalence is 3 dashes over one another. A common example of logical equivalence in discrete math is contradiction. So one example of this is Q and not Q is logically equivalent to not P and P, meaning that whatever values you put in for P and Q, it will always be false. On a similar vein of logic, a tautology is no matter what value you put in for true or false for P and Q, it will always be true. What is logical inference? That is a great question. Logical inference is a way to determine the validity of an argument using propositional logic. The two examples I'm using from the side books are resolution and disjunctive syllogism. The example for resolution is assume x is 5 or x is 1/5. We know x is not 5 or y is 3, therefore x equals 1/5 or y is 3. And I split up what P is equal to, Q is equal to, not P is equal to, and R is equal to. And then I put that into the formula to the left of resolution. So P or Q, not P or R, therefore Q or R. With disjunctive syllogism, the example is I cooked eggs or bacon. I didn't cook eggs, therefore I cooked bacon. And I split it up as well. So P is I cooked eggs, Q is I cooked bacon, not P is I didn't cook eggs. And as you can see, the format matches. P or Q, not P, therefore Q. What are quantifiers and what are their negations? So existential quantifier is what we'll start with. The symbol for that is a backwards E. The meaning of existential quantifier followed by an X means that there exists at least one X. And that X doesn't have to be there. It can be any variable you use. The negation of an existential quantifier is a universal quantifier, which we'll talk about next. So the universal quantifier is an upside down A. The meaning of universal quantifier X means for all X. And similar to existential quantifier, it doesn't have to be X. It can be any variable. And the negation of a universal quantifier is an existential quantifier.